In this lesson, we will study the Treasury bond futures. Futures contracts on 2-year, 5-year, and 10-year Treasury notes and Treasury bonds are available on Chicago Board of Trade. These futures contracts are useful for managing short, medium, and long-term risk exposure to interest rates. We will focus on the T-bond futures here. The underlying instrument for the T-bond futures is a hypothetical 20-year, 6% semi-annual coupon bond with a par value of $100,000. The futures price is quoted using the 30-second notation for each $100 face value. For example, if the March T-bond futures settles at 104-15 or 104'15, the long position is entitled to receive this coupon bond for a dollar price of 104 plus 15 30-seconds, which is equivalent to $104.46875. For $100,000 face value, this gives $104,468.75. Each T-bond futures contract calls for delivery of deliverable-grade U.S. T-bonds with $100,000 face value at expiry. The bond delivered must have at least 15 years to maturity or the first call date if it is callable. The short position can choose any business day in the delivery month to deliver, although contracts are rarely settled with actual delivery. While prices and yields of the T-bond futures are quoted in terms of the hypothetical bond, the short position of the contract could pick from a list of actual Treasury bonds which are acceptable for delivery. A well-defined mechanism computes from the quoted price to give the effective futures price for all the bonds which meet delivery requirements. The invoice price consists of two parts: the claim price and the accrued interest, where the claim price equals the settlement price times the contract size times the conversion factor of the bond chosen for delivery. The conversion factor is the claim price of a $1 face value coupon bond with a maturity equal to the delivery bond if it were priced to yield 6%. The maturity is measured from the first day in the delivery month, and the yield is compounded semi-annually. Note that, for simplicity, maturities are rounded down to the nearest quarter. Now let's calculate the claim price of a coupon bond with $1 face value and 6% yield to maturity. Let W be the percentage of the coupon payable to the bond buyer. As coupon periods are of 6 months length, the rounding down process leads to W being either half or 1. Assuming there are n remaining coupon payments, the full price of the bond is the sum of all the future cash flows, including the principal and the n coupons, discounted at 6% yield rate with semi-annual compounding. Subtracting the accrued interest C times 1 minus W from the full price, we get the claim price, which will be used as the conversion factor for this coupon bond. The following two examples will illustrate in details how to calculate the conversion factor for a coupon bond with given time to maturity. First, let's consider the bond with 19 years and 2 months to maturity. Rounding down to the nearest quarter, the bond has exactly 19 years to maturity, and the nearest coupon will be paid in 6 months from now. Since the coupons are paid semi-annually, there are exactly 38 coupon payments. Therefore, in this particular case, W will be equal to 1, that is, no accrued interest in the computation for the conversion factor. More precisely, it is just the sum of the discounted face value and the discounted coupons. Note that the 13% coupon rate gives a 0.065 semi-annual coupon for $1 face value. and the discount factor is calculated from the 6% yield rate with semi-annual compounding. Thus, we get the conversion factor for this coupon bond being 1.7872. Second, let's consider the same coupon bond, but with 19 years and 4 months to maturity. Rounding down to the nearest quarter, this bond has 19 years and 3 months to maturity, and the nearest coupon will be paid 3 months from now. Therefore, in this case, there are exactly 39 coupon payments. The corresponding W will be equal to half, and we have to take into account the accrued interest in the computation for conversion factor as well. Note that, in practice, we are spared the trouble of computing the conversion factors, as Chicago Board of Trade regularly publishes a table of eligible T-bonds for delivery for a certain T-bond contract, along with their conversion factors. For T-note futures contracts, they work similarly to T-bond futures, but with different deliverable securities. There are also restrictions on the deliverable T-notes and the use of conversion factors. Here's an example of a T-bond futures contract. Suppose the contract settles at 96-10, and the short position chooses to deliver T-bond with a conversion factor of 1.58. Then, the clean price is given by the contract size times the settlement price times the conversion factor, where the contract size is $100,000, and the settlement price per $100 face value is 96 plus 1032 seconds. Note that, in addition to the clean price, the long position on the futures contract must also pay the counterparty the accrued interest on the bond delivered. In practice, the party with short position can choose from among the deliverable bonds the cheapest one to deliver. Consider the party with the short position of the futures. On the one hand, for the delivery of the bond, it receives per $100 face value an amount of the quoted futures price times the conversion factor plus the accrued interest. And on the other hand, the bond delivered is purchased with the cost of the quoted bond price plus the accrued interest. Therefore, the cheapest to deliver is the bond for which the following net cost is minimized. Let's take a look at an example. Suppose that the party with the short position on the T-bond futures contract decides to deliver and is trying to choose among the 3 deliverable bonds in the following table. Given that the quoted futures price for delivery is $93.25, can you determine the cheapest to deliver bond? Substituting the quoted prices and the conversion factors listed in the table to the above formula accordingly, we get the net delivery costs for all the 3 bonds, by comparing which it turns out the cheapest to deliver bond is bond 2. To this point, we have finished the topic of the T-bond futures. Next lesson, we'll talk about the forward rate agreement.